Okay, so here I will shortly tell you about testing the Finto AI service. So in a nutshell, this little test was done by the subject cataloging expert group, which is in Finnish sisällönkuvailu asiantuntijaryhmä SISKU. And they launched actually a work group for automated indexing earlier this year. And we started working this spring also, and designed and carried out tests on Finto AI, which is like a service that runs on Annif. So it's basically the same thing as Annif, but it's the sort of the production version of it. And so our test was not supposed to be like a full usability study of the service, nor did we aim for like really hard scientific scrutiny. So we just carried out a small test of Finto AI as it is used by expert catalogers in their work. So we had 8 professional subject indexers or catalogers who carried out the test. And in the test, we used the Finto AI service and its web form. Okay, and the material the indexers used was the same kind of material they usually work with in the first place. And we had a form done for them where they could keep track of how well the Finto AI worked for them. And they could keep track of the material and also mark discarded or added subjects there. So this is how Finto AI looks for those who haven't actually seen it. So it's a web page, form, and some buttons to adjust your options. So you can choose a vocabulary, language, a number of suggestions you would like to receive. Also, you can change the language so that you get suggestions, for example, in another language. So if your text is in Finnish, you can ask Finto AI to give you suggestions in English, for example, or another language. Looking like this. So here I just copy pasted some text there. This is an abstract of a thesis, a PhD thesis in English, and I wanted to have terms in the same language as the text is, so in English. And as you can also see here, you can also copy these suggestions if you would like to. You can copy them as text, or you can copy their URI from Finto. So this is our brief results. So the indexers used material, kind of varying material. So there was fiction involved as well. But I discarded those results here because you know Finto AI is not optimized for fiction material. So I only focus on non-fiction here. And this non-fiction material was books, like popular science books, and articles and theses. And yeah, we had also 3 languages involved. So as you see, the general Finnish ontology has 3 languages, so we used all of them here. And I would like to note that, for example, the English material, we had very little of it. So yeah, and also Swedish material, we had very little of it. So we had the most of the material was actually in Finnish. So I looked at the percentage of suggestions from Finto AI or Annif that the indexer actually approved of. And then when the indexer made their final work, then how much of this final set actually comes from Finto AI, because you know sometimes you had to actually add more words there. And these are the brief results. So on average, so like 63-65% was accepted. So that is actually in line with our previous findings, and we were quite happy with those results. We also asked the catalogers for some comments. So here I list some of those. So using Finto AI doesn't necessarily speed up the actual workflow, but it can be helpful when it comes to general quality and consistency. And we also noted that sometimes subjects that are almost correct can be like a bigger pitfall than those who are like just blatantly incorrect, which you can easily ignore. And Finto AI was seen to be fast to use from a technical viewpoint. And then some hopes and wishes for the future. Maybe Finto AI should support more vocabularies. And of course, it should be updated regularly. And it also might be, okay. So some people viewed it as very important for Finto AI to have a link on the web page where you could submit a term suggestion to the general Finnish ontology YSO. So for example, if you note that, okay, something seems to be missing here, then you can press a button and notify the upkeepers of the YSO that they might need to add something to the actual vocabulary. And this would be very convenient to do while using Finto AI. And also there's the copy button I showed. And currently it doesn't allow you to copy all of the suggestions at once. So maybe that would be an option in the future. So you could just copy them in bulk. So these are some of the general comments I received during this test. So yeah, that was a short and quick presentation. Thank you for listening. And if you have any questions, I'll be happy to answer them. Yes, Mikko Lappalainen.
Yes, hello everyone. I have one question for the persons. I think there are some of the group of Cisco group online right now, and my question goes like this: that would you consider it a good thing to have Annif or Finto AI doing indexing, so that no professional would actually go through it for materials that would otherwise not be indexed at all? Would it be a sort of benefit to have automatic indexing done by Annif or Finto AI, or no indexing at all for some materials? Based on this test that you have now done, very interesting. Thank you.
Yes, if any Cisco members would like to speak. Okay, so, and feel free to interrupt me, but in general, it's better to have a human look through these automated suggestions, especially if those suggestions end up somewhere really important and much used. But okay, then there's the trade-off. So if there is material that is like otherwise would remain untouched, then there are cases where it just would be more useful to have at least something there rather than nothing. So there's a bit of a trade-off there. And if your goal is just to have some indexes, then of course, you know, automation is just one way to achieve that there's at least something for everything. But if you are really want to focus on the quality and its usability, then you just, you know, have to recommend that an actual person goes through it. Yeah, and you can also write your answers on the chat, of course.
Yeah, the sort of why I'm asking this is that we know that there are tons and millions of materials that have no indexing terms at all. And of course, the one thing that we can benefit from using ANIF is to help the human indexers in their work. But the other side is that could we perhaps get more indexing done using ANIF, although we would have no professional indexers going through the terms. So that was sort of the rationale behind my question.
Yes, Lauri Lähmuskenttä, you can take your turn.
Not related to question, but that we just discussed. But I was wondering, the people that were answering doing the research, right, and group, they said that the ANIF didn't speed up their work. Was there any reason why it doesn't speed up? Do they have to check the words anyhow, or was there any reason mentioned for this?
The reason is exactly that which you described. So they will still have to like check everything and make their own decisions. And it generally didn't, they felt that it didn't speed up the actual workflow because you still had to copy paste text there and go through all of the suggestions. And then you have to like, I mentioned the pitfall where something is like almost correct. So you have to take your time and ponder if this is acceptable or not. So it still takes time to do the work. So I didn't make it like a, run faster by any means, I think. Yeah, like as Mirja said, you have to make sure that the work is correct. So you still have to check it. That takes time, in brief. But of course, this isn't the only use of ANIF. For example, we have these institutional repositories, which also receive suggestions from ANIF. That's a different use case altogether. Okay. So now if there are not any more questions on this part, you can also continue your discussion on the chat. But now I would like to give the floor to Osma and Juho, and we can go through the results of the workshop.
Yes, thank you, Mona. Yeah, during the break and the previous presentations, we run a really quick analysis of the results. But first, let's take a quick look at the materials that were used in this workshop. There were 60 different documents that were gathered from 6 repositories. 20 of the documents were master's thesis in Finnish, 10 from the repository of Jyväskylä University, 10 from the University of Vaasa, and then there were some thesis and general publications in Finnish, 10 from the repository of University of the Arts, and 10 from Theseus, which is a repository for many universities of applied sciences. And then there were 20 PhD theses in English that were gathered from the repositories of University of Lapland and from Tampere University. So for every document, we had 6 to 8 subject sets which were created by different indexing methods. Always two subject sets were human origin. One subject set was collected from Fennica database or created by Fennica persons for this workshop. And also one subject set of human origin was gathered from the repository where that document was stored. So the other human origin subject set was created by a student or a librarian of a repository. Then we had subject sets created by ANIF or different algorithms in ANIF. The M, LLM, fast text, and Omiguchi are kind of standalone or base algorithms. But then the neural network ensemble is an algorithm that combines the suggestions from the base algorithms, and it is expected that the neural network ensemble gives the best results of them among the ANIF algorithms. We also wanted to compare if it's possible to use only an abstract as an input to ANIF instead of full text. And also we tried if it's feasible to use machine translation from English to Finnish, and then the translated text is used as the input for ANIF projects. Then some overall numbers of this workshop. First, there was 32 participants who filled at least one review, and all of the 60 documents received at least one review, or one of the subject sets received at least one review of all the documents. And there were over 400 different subject sets that received reviews, but the total number of reviews was over 1,000, which is actually a bit less than in the previous workshop in 2019. But yeah, these two numbers mean that every subject set, or on average, subject set received 2.6 reviews. But then to the actual results. Here are the three different metrics that were used, and here is the percentage of removed subjects. Well, it is seen that the subject sets by Fennica have received the best grades on all the metrics used. But then actually on the second place is the ANIF neural network algorithm. Also, this is on the second place on all the on every metric. But on the third place is then the subject sets which were gathered from the repositories directly. And then come these base algorithms of ANIF. And the percentage of the removed subjects quite closely reflect the grade ordering. But here actually the human repository subject sets are on second place by a small margin. Yeah, this was a really quick analysis of the results, but there's also a comparison to the results of the previous workshop, which was very similar to this. And we were hoping that we would see some increase in the UNIF grades. Here's the plot of only the Jyväskylä University thesis, which were the same documents in the both workshops, but really the grades for these documents have not improved much. But actually on the percentage of removed subjects has decreased. So this can be as an improvement of UNIF. But yeah, these were really quick analysis results, so we need to take a closer look on the results still. But maybe Osma can now continue on the example documents.
Okay, thank you, Juho. So I will show a few example documents and what kind of subject sets were produced and what ratings they got. So here is one. Okay, the documents and the subjects are in Finnish. Sorry, Cora, but that's what we have. This is from the University of Arts. It's history of the teaching of dancing and theater on master's level during 10 years. So yeah, it's like a it's documents the history of this teaching at that university. And so here you can see the legend for the colors here, and these are the average grades. So the average of all three metrics that we used. And in this case, this purple one is are the subjects that were given to the document in the original repository, and it was considered it got the best grades. And the second best was actually this red one, which is the neural network ensemble. So this is like the best that UNIF can provide. And the third best was the subjects given by Fennica, given in Fennica in the National Bibliography. And the base algorithms of UNIF were clearly much worse, but the ensemble actually was pretty good. So in this case, the UNIF indexing did very well, I would say. Then this is another document, and this is a description of a project in XAMPP Kaakkois-Suomen. It's in an applied university. It's a project for description of a project where gases in biorefineries were used and developed. And in this case, all the grades were quite bad, actually. And the best one was still the one in Fennica with an average score of 3.3. And the algorithms didn't do very well, and also the original subjects from the repository were not given very good grades either. So we can see here that in the subjects, in the UNIF produced subjects, there was always Kaakkois-Suomi, which is actually comes from the name of the university. It's the part of Finland that is where it's located, and so it's not a good subject for this document. Okay, then this is a master's thesis from the University of Vaasa, from the Osuva repository. This is related to social services, social policy. It's the sad topic. It's about huostaanotto. It's when children are taken away from families that cannot take care of them, and this was actually about when it's possible to return the children back to their parents. Anyway, in this case, it's the results are a bit curious because all the UNIF produced subject sets were judged as being better than the human produced ones. I think this is an exception, and it might be just that I didn't check the number of reviews here for these documents, so it's possible that it was only one person giving the ratings here. But it's a bit of a surprise that the algorithms are rated as much better than the humans in this case. Okay, and then finally this one, this is a dissertation from the University of Tampere. This one is in English. The topic is regulating human behavior with vibrotactile stimulation. It's some kind of advanced user interface research, I think. And in this case, the original subjects from the repository were judged as the best ones, and the second best one was Fennica. So this is maybe not a very surprising result, that the human subjects are considered the best, but UNIF, the neural network ensemble, isn't far behind here. So it did quite well on this one as well, even but this is in a different language than the other ones. That's it for the example documents. Then there was the question of how well did we distinguish between human versus machine indexing, and we did a quick analysis here. And here, I'm sorry. Yeah. Here we can see that this is the difference between the human. The grades given to human indexing and the grades given to the best UNIF algorithm, the neural network ensemble, and we can see that about half the participants gave better scores to the humans, those here on the top, and about half of them gave better scores to the algorithms. So it was really hard to distinguish which one came from where, or at least based on the scores. So you couldn't tell, or it was a difficult task to. Oh, of course, this wasn't the main task. Wasn't to identify which one is the human, but anyway, it's really hard to tell which one is it. And that's it from my side. This was, like Juho said, this was a really quick analysis. We will probably do more analysis later and maybe publish it like we did last year in Tietolinja magazine. So somewhere we will produce a more detailed analysis of these results. But thank you very much. We couldn't have done this without you, and I hope you enjoyed it.